Assalamualaikum. Okay, today I would like to discuss on the solution for the assignment 1, which comprise of 4 questions, question 1 till question 4. Okay, for the first question and for the question 2, I just want to give you the overview of the solution without maybe step by step calculation, but just consists of the way how you can solve the question in general, and I will give the final answer for you to compare with yours, and then but the important one is you understand the step by step solution of each question. Okay, so for the first question, 1 kilogram of water undergoes a cycle that consists of process as described below. So from process 1 to 2, isobaric expansion of saturated liquid to saturated vapor. Process 2 to 3, isochoric cooling to 80 degrees C. Process 3 to 4, isothermal compression. Process 4 to 1, isochoric heating back to 400 kPa. So you can refer the question back in order to follow this solution. Okay, for the question 1, the pure substance given is water. So you will refer table A4, A5, A6, maybe A11, related to the answer that you are going to get. For example, if the phase is superheated vapor, then you need to refer table A11 if I'm not mistaken. Okay, and then process is cycle, mean process 1 to 2, 2 to 3, 3 to 4, and then back to its original state. Okay. Okay, let's move to the process 1 to 2, which is isobaric expansion, means isobaric is constant pressure. So we directly know the pressure 1 at state 1 equal to pressure at state 2. And it gives the description of process isobaric expansion of saturated liquid to saturated vapor. We already know that at state 1 the phase is saturated liquid and phase 2 is saturated vapor. So if we refer to the question, the question A, sketch the PV diagram of the cycle process and label the diagram appropriately. So you can start with a PV axis and label its unit, pressure kPa, and specific volume will be cubic meter per kg. And then you will have the curve represent the saturated liquid and saturated vapor line, and you may also put the point 1 represent the state 1 and point 2 represent the state 2, which represent by purple color of numbering and line. So you can have pressure 1 equal to pressure 2 under on the line of temperature. Okay, next process 2 to 3, which is isochoric cooling to 80 degrees C. So from this description, we know that isochoric is constant volume, means V2 equal to V3. So from the PV diagram, you can put the point 3 in parallel with point 2, which represent isochoric cooling to 80 degrees C. And then from the description also, we know that the temperature of point 3 is 80 degrees C, because it's stated here the process is cooling from temperature 2 to 80 degrees C, which is temperature 3. Okay, next process 3 to 4 and 4 to 1. From process 3 to 4, isotherm expansion, we know that constant temperature, which is T4 equal to T3, 80 degrees C, and process 4 to 1, which is cycle back to state 1, is isochoric, so that we know V4 equals to V1. And then if we plot the point, each point on the PV diagram, we can have the PV diagram as shown in this slide, which is a cycle process, state 1 to 2, 2 to 3, 3 to 4, and 4 to 1, with P1 equal to P2, P3 equal to P4, as well as T3 equal to T4, and V1 equals to V4, and V2 equals to V3. So here from the PV diagram, it gives you the hint on what properties that you are going to have directly from the table, maybe E4, A5, mixture, A6, which those that are related to what you need. Okay. Okay, then for question 1B, the question asks to measure or determine the heat transfer for each process. Okay, then from the PV diagram, each process means the Q for process 1 to 2, Q1 2, Q2 3, Q3 4, and Q4 1. So based on the process, whether it is isobaric, isochoric, isothermal, or any other constant properties, so you need to derive the related heat transfer formula. Okay. Okay, for first heat transfer from process 1 to 2, which represent by Q12. First, we need to start with general energy balance. So Q minus W equal to delta U plus delta KE plus delta PE. Since the question stated that assuming both kinetic and potential energies are negligible, so we cancel delta KE and delta PE. The remaining formula will be Q minus W plus delta U, and this W or WB can represent by P naught delta V. So expand the P naught delta V we have Q minus P naught multiplied by specific volume of state 2 minus specific volume state 1 equal to delta U. And rearrange the equation, we have Q equal to delta U plus PV. If delta U plus PV can represent by delta H, so the final formula for Q12 equal to M multiplied by H2 minus H1. The value for H2 and H1 we can get directly from table A5. Considering the pressure of P1 and P2 equal to 400 kPa, so that we directly refer to table A5. P equals to 400 kPa and H2 at state saturated vapor phase, so you will get the value of Hg. And for H1 at state of saturated vapor, so you will have the value for Hf. And given the mass of water is 1 kilogram, so you will get the value of heat transfer for process 1 and 2. Okay, next process 2 to 3, which is isochoric cooling to 80 degrees C. From the PV diagram, you need to find the Q23, and again from the energy balance analysis, Q minus W equals to delta U plus delta KE plus delta PE. Okay, because of the process is isochoric, so the work boundary will be 0. The remaining formula will be Q23 equal to delta U. So expanding this delta U equal to M mass of water multiplied by U3 minus U2, which the value of U3 is the average internal energy of the water at 80 degrees C. So you need to find the quality, which is X. So how to find the X? You need the value for a specific volume, which is V2 equal to V3, and you may get the X by using the value of specific volume. I believe that you can solve this equation by yourself. Okay. Okay, lastly, for process 3 to 4 and 4 to 1, same step of calculation as in the previous slide for process 3 to 4, which is isothermal compression, and it also isobaric process, because you can see here the pressure of state 3 equal to pressure at state 4. So we directly derive the energy balance for this process, Q34 minus W equal to delta U plus delta KE plus delta PE. And as we know, delta U plus WB will be delta H, and expanding this formula, Q34 equal to M multiplied by H4 minus H3. And for the Q41, because of the isochoric process, so that the WB will be 0. The remaining formula just Q41 equal to delta U. Expanding this delta U and multiply by U4 minus U1. So that's you can determine all the heat transfer for each process by using this formula. Okay, end of the question 1. I will continue with question 2 in the next recorded audio. Okay, thank you.